Hi, I'm an old guy and I do maths. And today we're going to look at how matrices can be used to solve simultaneous equations. And we have a pair of equations here, which we could solve very easily using elimination or probably substitution with a little bit of work. But just so that you can see how this is done using matrices, that's what we're going to do. Now, where this really comes into its own is where you have much more complex setups than this. So you might have x, y, and z, or w, x, y, and z components, and four equations. As I say, that's really where matrices come in handy. Okay, so there are a couple of things to be aware of. So we'll get started with the first of those. Now, the setup for this is that we create a series of matrices. And the first one we normally call A. I certainly have called it A. And that consists of the coefficients of x and y, in this case, in this order. So basically our first equation, the coefficients go across the first row. The coefficients of the second equation go across the second row. X and y are in a column matrix in this order. If you went to a 3 by 3 problem, it would be x, y, and z. And 8 and 14 sit out here as C. So basically, we're just rewriting this in matrix form. So we wind up with 2 times x plus 3 times y, which is how you multiply a matrix across and down, and 4 times x plus 5 times y, and they equal 8 and 14 respectively. Now, looking at this, we want to find out what x and y equal. Now, straightforward algebra would suggest the following. If a times b equals c, we can find b by dividing c by a. Problem. You don't divide using matrices. It doesn't happen. So what we have to do is we have to multiply by an inverse. So b is equal to c times a negative 1, or a negative 1 times c. That's how it will work with matrices. But that's the basic algebra. We have to change the sign and find the inverse of this. So let's get to work on that, which is all of this working here, which does actually get us to a solution. So I'll just talk you through all of this. So the first thing we need is the inverse. Now, the inverse is made up of 1 over the determinant. If you don't know what this is, there is a video on how this is calculated. And indeed, if you don't understand the business of the inverse of a matrix, there is a video on that. But this is just a quick rerun. So it is 1 over the determinant times the rearranged form of this matrix here. We swap these two, so 2 and 5 swap positions. These two are made negative. And when we work all that out, we will have a to the power of negative 1, the inverse of a. Here it is partially worked out. It's negative 1/2 times 5 times negative 3 times negative 4 times 2. And that gives us the following. Negative 5 over 2, 3 over 2, 2, and negative 1. And if we multiply that by C, which was this matrix up here, 8 and 14, we will wind up with solutions for these two equations. Now, the order that you do this in is important. This is a 2 by 2, and this is a 2 by 1. You can't do it the other way around. The rules of matrix multiplication don't allow you to do that. So if you start trying to multiply this by this in that order, you're going to run into trouble. If you do it on a calculator, it'll refuse to do it. If you do it by hand, I have no idea what will happen. what we're going to wind up with is a 2 by 1 matrix, which is what we'd expect. And the reason that we can multiply these two matrices together is because that number and that number are the same. Okay, so when we do that, we get negative 5 over 2 times 8 plus 3 over 2 times 14. And that gives us these values up here, and we eventually add those. Then we take the second row, 2 times 8, plus negative 1 times 14. And we get the following, 2 times 8 plus negative 1 times 14. When we sort all that out, we get negative 20, which is this value here, plus 21, which is this value here, which gives us 1. And 2 times 8 is 16, minus 14, which gives us 2. And this is our matrix B. That is the solution for B. And from that, we get x equals 1 and y equals 2. We can see how that works up here. 2 times 1 is 2, 3 times 2 is 6, 6 and 2 is 8. 4 times 1 is 4, 5 times 2 is 10, 4 and 10 are 14. That is how you do a simple pair of simultaneous equations using matrices. It does get more complicated than this, and there will be examples in the playlist. I hope you found this useful. If you did, please like and subscribe. Thank you for watching, and see you next time. Bye.